Well, hello. Welcome to our final lesson for this unit, Unit 6, Lesson 10, Indirect Measurement. We're going to be piecing together indirect measurement. So this is where you can measure distances without actually being there to measure them. So you can see here, these students are going to measure their shadows. Well, actually, they can measure their shadow, and then you can use shadow measurements to measure heights of objects, really tall objects. Like buildings, if you know your height, your shadow's height, and the building's shadow's height, you can figure out the height of the building without actually measuring how tall the building is, because it's kind of dangerous to measure how tall it is. So you can do it with smaller objects. In this example here, you can measure the height of the statue with the shadows, the statue's shadow, your height, and your shadow's height. What you can do is you can make two similar triangles, similar figures, and you make a proportion out of it. Okay, pretty basic. You can set your proportion up 3 different ways. You can go sideways, big to small, big to small. You can go vertical. You can go your height to your shadow, to the statue's height to the statue's shadow, or you can go the other way around. You can go this way to that way, or you can go this way to that way. So I guess there's 4 ways. So you can go horizontal 2 ways, you can go vertical 2 ways. But either way, you're going to set up a proportion. And when you solve any proportion, it's always cross multiply or divide. So in this case, this example here, we're going to do number 1 on page 238. We have a bell tower casts a 27.6 foot shadow at the same time nearby. A tourist casts a 1.2 foot shadow. Now we know since the sun's so far away, we can use shadows to determine because it's so far away, 93 million miles on average, it makes similar triangles. Okay, it's so far away, there's no real difference in the angle. Especially if they're standing really close together. If the tourist is 6 feet tall, how tall is the tower? So I like to put the smaller number on top. So we'll do shadow on top, height of the tourist on bottom. So the shadow of the tower goes on top, and we don't know the height of the bell tower. So we're going to cross multiply. We get 1.2x equals 27.6 times 6. 165.6. Now, once we cross multiply to solve the proportion, we divide. I wrote 2. That should say 6. That's backwards. 6 kind of. Divided by 1.2 equals 138 feet. So x equals 138. And make sure to put your label on at this point, feet. Now, we can also use this, instead of using shadows, using the sun, we can use this for surveying distances, such as a pond here. So you can measure this distance here, this distance here, this distance here, and you can make similar triangles that are kind of reflected and reversed and mirrored and reflected. So we know these are the right angles, so this is similar to that. This side is similar to that side. So when we set it up, just be careful what side goes with what. So in here, the key is how it's written. We know that QRS is URT. They're similar. So QRS, so we're going in this direction. URT. So that means 60 and X are similar. And that means RT, RS. So I used the smaller triangle first. I'm going to do smaller triangles. Smaller triangle second, 138 second. Same thing here, cross multiply. 60 times 138 is 8,280. 46 times x is 46x. And I was going to go to my calculator on that one. That's embarrassing. So 8,280 divided by 46 is 180. Don't forget your label. 180 what? Yards is labeled in the problem. So I can measure the distance between the mess hall and the cabin, knowing these other distances here without actually having to walk it with some sort of measurement device. Usually you have something like a wheel with a ticker on it that measures distance in yards for every rotation. All right, that is it for today. If you have any questions, email me, message me on campus, talk to me in class. Do whatever it takes to dominate this lesson. Talk to you soon. Bye.